Honors Pre-Calculus 2013 Final Exam Review, number 64. So number 64 asks us to make a graph, and it gives us a sine function. And they make a little graph here, but I don't like using a graph that somebody else drew, so I'm going to probably end up drawing my own graph. Now, let's write the problem here for number 64. So we have y equals 2 plus 1/3 sine of 2x minus pi. So our first job is to identify all of the parameters. So we're going to find the parameters, and then we're going to find the key points. So we need to know, we're going to use key points. And I keep using this word parameters. Parameters means we have certain numbers that control certain aspects of the graph. So for example, one of our parameters is A, the amplitude. Now for a review of what in this function are A, the amplitude, omega, the frequency, C, which we use to find phi, and the vertical shift. For a review of those, look back at number 54, and it will remind you what all these things do. Some people, by the way, call this omega, they call it B. So if you want to review all these variables, look back at number 54, and it will tell you how to find things like period and amplitude and phase shift and so forth. So we're going to notice first that our A is 1/3, and remember, if this were negative 1/3, we would still say the A is 1/3. A is an amplitude in its absolute value. The next thing we want to notice is that the omega is 2, so that's the coefficient of x, so it's 2. We want to notice, the next thing usually that I get after omega is I will find the wavelength. So the wavelength is lambda, and it's equal to 2 pi over omega. And so our omega is 2, so that is 2 pi over 2, which equals pi. So our lambda is pi. The next thing I might want to notice is my phase shift. So my phase shift phi, so we usually call that a negative c over b, the b being the same as the omega. So that would be negative pi over 2, so that's positive pi over 2. So that's our phase shift. And then the vertical shift is the 2. Sometimes the 2 appears over here, plus 2 as a vertical shift. Sometimes it appears at the front, doesn't matter. So our vertical shift is 2. Now, the next thing that I'm going to do is find my key points. I'm going to find the x coordinates. So first we get a starting point. So one thing you want to remember is that your phi is the starting point. So that's our starting point, is pi over 2. The next thing we need is a value for what we call k, or what I call k. Some teachers call it different things. K is how you're going to determine what we're going to move up by each time. So k is equal to 1/4 lambda. I'm not sure that color is showing up, so let's, what are all my colors? Let's use purple. K equals 1/4 lambda. So that means our k is equal to 1/4 times our lambda was pi. So that equals pi over 4. So that's our k. Now what we're going to do with the pi over 4 is we're going to add it to pi over 2. So we're going to add plus pi over 4. Now we might have to think about what is pi over 2 plus pi over 4. If I do pi over 2 plus pi over 4, I have to get a common denominator and call that 2 pi over 4 plus pi over 4. And that's equal to 3 pi over 4. So my next point is 3 pi over 4. That's my next x coordinate, 3 pi over 4. Now, if I'm going to keep adding pi over 4, and I can get common denominators and simplify every time, but the simplest thing really to do here is, once we know that pi over 2 is 2 pi over 4, then we can say this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. We keep going until we have 5 points. Each of these graphs has 5 key points. So now I could go after the fact and reduce this 4 pi over 4 to pi, and this 6 pi over 4 to 3 pi over 2. But even for the sake of graphing, it's going to be easier to leave them unreduced to start. Now, these are my x coordinates of my key points. So I found the x coordinates of the key points. Now I need to find the y-coordinates of the key points. So one way that I find the y-coordinates of the key points is by thinking about the basic graphs of y equals sine x, which we know looks like this. So the y-coordinates go like this: 0, 1, 0, -1, 0. So I use that pattern for sine of x. For sine of x, my y-coordinate pattern is 0, -1, 0, +1, 0, -1, 0. Then for cosine x, my y-coordinate pattern for y equals cosine x, since cosine x looks like this, that pattern goes 1, 0, -1, 0, 1. So for cosine x, I use 1, 0, -1, 0, 1. So these are my y-coordinate patterns that I use for sine and cosine. So for sine, my y-coordinates are going to start by following this pattern, the sine pattern: 0, 1, 0, -1, 0. And I want to keep these matched up with the corresponding x coordinates. Now, the next thing that I need to do is consider the effect of the amplitude and the vertical shift. These two affect the y-coordinates. So here are our basic y's, but first I need to multiply them all by the amplitude. So times 1/3, that's our amplitude. So that will give me 0, 1/3, 0, -1/3, 0. And then I need to consider the vertical shift, and I'm going to add in the vertical shift. So the amplitude we multiply, the vertical shift we add. So we're going to now add the 2 that is the vertical shift. So we're going to add 2, we're going to add and make, we'll just call that 2 1/3. Keep it nice and simple. 0 plus 2 is 2, -1/3 plus 2 is 1 2/3, that's 2/3, and 0 plus 2 is 2. Now what I want to do is recognize that these are points that I am plotting. Pi over 2, 0. 3 pi over 4, 2 1/3. 4 pi over 4, 2. 5 pi over 4, 1 2/3. 6 pi over 4, 2. Now I'm ready to make my graph. So I'll draw some coordinates here. I tend to normally draw only the positive side. Now, your answer sheet only gave you the first quadrant, but we're probably going to have to, well, I don't think we have to go below because of the vertical shift. But I'm going to draw the positive side, and then if I need to, I'll add in the negative side. I know it's over there, but we might not need it because all of our x coordinates are positive. So the first thing I need to do is get these x coordinates on here. So I have to remember that this pi over 2 is 2 pi over 4. So I can't start with pi over 2. That's 2 pi over 4. So and I'm going to count by pi over 4s. So in this list where it goes 2 pi over 4, 3 pi over 4, pi over 4, I have to start with 1 pi over 4. So 1 pi over 4, then 2 pi over 4. And now let's think of our 2 pi over 4 as being pi over 2. And then we'll reduce these as we put them in. 3 pi over 4. 4 pi over 4 reduces to pi. 5 pi over 4. And then 6 pi over 4 reduces to 3 pi over 2. So, but you see that by not reducing them until I put them on here, it helps me get them all in the correct order. And I don't have to remember, for example, that it goes pi, 5 pi over 4, 3 pi over 2. That's difficult to remember. But if I leave them unreduced, it's easy to see 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. We just put them in that order. All right? Next, I need to plot these y-coordinates. So I notice I have some 2's and some 2 1/3. So let's call this 1, we'll call this 2, and we'll call this 3. It's imperative that I label the x-coordinates and label the y-coordinates, because if I just sketch something, it's wrong. So because we need to show that we understand where things are. So now, let's plot this point, pi over 2, 2. Pi over 2, 2. Then I have 3 pi over 4, 2 1/3. 3 pi over 4. Now 2 1/3 is going to be 1/3 of the way up to 3. Now we're up to 4 pi over 4, 2. 4 pi over 4, 2. 5 pi over 4, 1 2/3. So that's 1/3 below the 2 line. And then I have 3 pi over 2, 2. So 3 pi over 2, 2. Now these make a nice line. Make sure you don't make them pointy. It's a nice curve, I should say, not line. It's a nice curve that goes like this. Now what we've drawn here using the 5 key points is one cycle. So we've drawn one wavelength. Here's our wavelength that starts at pi over 2 and ends at 3 pi over 2. So we can see that that wavelength, the length of a complete cycle, is pi, because it goes from pi over 2 to 3 pi over 2. Now, the direction said, graph the function over a 1-period interval. That's the same as one cycle, 1 period. So I've done what the directions have asked me to. But as a point of understanding for you, you might want to show, I know not only that this keeps going in both directions, but it keeps up the same pattern. So every pi over 4, I'm going to go down and up and center. This one's going to go up and center, right? So I could extend that curve in a fairly careful way if I wanted to. So if the exam says just draw one cycle, we'll just draw this purple part. And if it says draw more cycles, we can draw more, following the same pattern. Once you get the 5 key points, you follow the pattern. So what did we do? We identified the parameters. We used the parameters to generate the x-coordinate starting from the phase shift. So that's negative c over b, negative this number over this number. And we started with that. We found our k, which is 1/4 lambda. We used the k to count up. Now we have all our x-coordinates. We use our sign pattern to write our starting values for the y-coordinates. If this had been a cosine function, the only thing that would change here is that instead of using these values, we would use these values. And we put these here, and we'd have different y-coordinates. But the only difference between sine and cosine is these values. Everything else in this work would be the same. It would only change here. All right, now once we've got our sign pattern in, we're going to pay attention to the amplitude and multiply, the vertical shift and add. We've got points now, 5 points. We plot the 5 points, we make a nice curve from them, we extend the pattern. And that's how you do graphing of sine curves. That's number 64. No! What are you doing?